All right, so got the pop up here. Okay, folks, so I wanted to work through one problem, and similar to something that we've done already in class recently, but and this should help you guys out with quiz number 6 a little bit. But this is a problem where, according to you probably need a haircut.com, and I think they're talking to me because my hair is getting a little bit out of control. 85% of people in the United States have black hair. And suppose 3 people are chosen at random, and they're selected their hair color, and their hair color is observed. All right. And so what we want to do is we want to try to find the mean and the standard deviation of these 3 people that have the number of those people that have black hair. All right, by using both the discrete probability formula as well as the binomial formula. Okay, and I think this is similar to the one problem on your guys' quiz number 6, where you guys have the multiple choice questions, and there's 4 multiple choice questions with 25% likelihood that you're going to select each one correctly. I think 1 out of 4. All right, so let me go ahead and work through this with you guys just to make sure you have an example of something like this, just in case something like this were to show up on your examination. Okay. So first things first, we want to make sure that we identify some of the key sort of characteristics for this. All right, so when I'm looking at this, it looks like that the sample size n is going to be 3. All right, it also looks like the probability of success is going to be 85% or 0.85. Okay, and then I think from there we can inherently find q, which is going to be 1 minus 0.85 or 0.15. And so now what we can do is we can start to be able to find this probability distribution based on the data. Okay, so remember, we need outcomes for probability distribution. We need outcomes, and then we also need our values. And then lastly, we need the probability. All right. And the probability is going to be the one that's a little bit difficult for us to get. Okay. If we have 3 people and we're looking at the number of those 3 that have black hair, one outcome is that we have 0 people with, I'm just going to abbreviate it, with black hair. And we have 1 person with black hair. And then we have 2 people with black hair. And then finally, we have 3 people with black hair. All right, so on your examination, on your quiz, don't just put 1, 0, 1, 2, 3. Okay, that doesn't make any sense. Okay, an outcome is some sort of event, okay, or some sort of qualified outcome. All right, so we want to make sure it's specific as to what we're looking at. Okay, all right. Next thing we're going to do is we're going to get the values. That's pretty easy. There could be 0, 1, 2, or 3 people with black hair. And then the last thing we need to do is we need to find the probabilities. Okay, now for the probabilities, this is where we're going to have to use our binomial distribution. All right, just because in this case, a success would be a person has black hair, a failure would be they don't have black hair. Okay, so what I'm going to do is, let's say we have 0 people. And let me set up the formula for this one. Okay, and so there are 3 people. Okay, so we're just basically finding the probability based on the binomial distribution. Remember, the formula is n combination x, p to the x, q to the n minus x. Okay, and that's going to be our p of x. All right, so that's how we're going to go through and try to figure out the probability for any of these sorts of number of people. So for p of 0, that's going to be, there's 3, of which I want 0. Remember, we said that p was 0.85. That's going to be to the 0. And then we're going to take 0.15, and that's going to be to the 3 minus 0. Okay. And what I'm going to do, I'm just going to throw that in my calculator. Okay, I'll write the instructions up just to make sure that in case you need the instructions how to put that in your calculator, I have those. All right, so if I type this in my calculator, and I don't know if anybody can verify this, but I get 0.0034 if I went out to 4 decimal places. Okay. And so what I could do is I could just fill in the probability back here on my chart. Okay. I think in class we just did all the binomial stuff right in there. Just because I don't have enough room on this, I'm just doing it on a separate page. Okay. Now the good news is, folks, once I have one of these, then what I could do is I could just go ahead and find P of 1, P of 2, and P of 3 just by changing the n value. Okay, so 3, 1, 3, 2, 3, 3. And then this will be 0.85 to the first, 0.85 to the second, 0.85 to the third, and then 0.15 squared, 0.15 first, 0.15 to the 0. Right? Now, what I'm going to do is I'm just going to stick these in my calculator. So if you just give me a second, and for those of you that have your calculators available, if you could go ahead and verify or just check to make sure that I'm doing this correctly. All right, so for the second one, I get 0.0574. And then for the third one, I got 0.3251. And then for the last one, excuse me, I got 0.6414 or 6141. Sorry, went backwards there. All right. Now, a way to check that you guys have done this correctly, and you may or may not remember this, is to add these up. Okay, so if you add these up, that's a way to check to make sure that at least you're in the right ballpark with this stuff. Okay, and so I'm going to add these. All right, so if you just give me a second while I type these in my calculator. All right, I ended up with 1. Okay, and that's good. Okay, that's what we exactly need to get. Okay, now remember, if you get like 1.001 or 0.999 or something like that, that's fine. Okay, but if you start straying significantly from those, then you might want to go back and just check to make sure that you're in the right neighborhood with this stuff. All right, so going back, I can fill in my probability distribution. So this was 0.0574, 0.3251, and then finally 0.6141. All right. All right. So that's probably the hardest part of these problems. Okay, is if I don't give you the probabilities and it's a binomial event, you guys are going to have to do something like this. Okay, so just as a reminder, how to put this in the calculator. Okay, what you guys are going to do, let me just go ahead and type, I'll type in, or I'll write out. So let's say we had P of 0. Okay, so that's 30.85 to the 0 times 0.15 to the third. Okay. Then to put that in your calculator, okay, so remember you hit 3, and then you go math. Okay. And then the next thing you do is you hit enter, or I'm sorry, you go to prob, and then you go to NCR, and then 0. And then once you're there, the next thing you do is you type in times 0.85 raised to the 0, and then times 0.15 raised to the third. Okay, and so in your calculator, it should look like this: 3 combination 0, okay, times 0.85 to the 0 times 0.15 cubed. Okay, and I think everybody, when they turned in assignment number, or I think it was quiz number 5, where you guys had to do those, I think everybody was pretty good with computing them. You might not have set it up correctly, but at least you can compute stuff. But I just wanted to remind folks, just in case they were having issues being able to compute. All right, so questions I can answer before we move on, okay, to the next parts of this problem. Okay. All right, folks. So going back, okay, I just want to make sure I remind folks as to what we're looking at. Okay, so okay, so we did this part already, okay, where we created the probability distribution. Okay, that's the hardest part for this problem. Okay, now what we want to do is we want to use the discrete probability formula to be able to find the expected number of people out of the 3 that have black hair. Okay, and then we're also going to interpret what that formula or what that value means. Okay, all right, so going back, maybe, going back here, right, this is where we want to fill in the rest of this table. Okay, now what I'm going to do is I'm just going to copy these 2 columns, okay, because obviously I don't have enough room on my screen to do that. Okay, so all right, so remember we had our x, which was 0, 1, 2, and 3, and then our p of x, which was 0.0034. Oh, stopped writing for a sec. Uh-oh. Not sure what's going on. Doesn't want to write for me. Doesn't mean class is over. Sorry. There it goes. 0.0574 and 0.3251. And then finally 0.6141. All right. So now the next thing we need to do is we need to find x times p of x. Okay. And this is where we're going through and we're just using the discrete distribution to be able to find what our mean is. All right, so when we multiply, this is going to be 0 and then 0.0574. And then I think this is going to be 6502. And this is going to be 1. I quit after that one. So let me make sure the other one's correct. All right, so that's 6502 and then 0.6141. We get 1.8423. So I'll just, yeah. Okay. And then what I'm going to do, folks, is I'm just going to add those numbers up, and that's going to give me the mean for this. Right. So I'm just going to add it up in my calculator. And again, if you guys can just verify it, just to make sure I'm typing things in, because I'm talking, I'm writing, I'm typing. It's pretty easy for me to make a mistake. 2 and then 1.8423. So I ended up with 2.5499. Okay. And again, that's going to be the mean. Okay, so mu is equal to this. Okay. Now, I think another thing that we have to do is we have to interpret this. And remember, this is the expected value, which means this is what I expect to happen after I perform the experiment a large number of times. Okay, so what this would mean is if I observe 3 people a large number of times, okay, I would expect it's 2.54 or 2.55, which is about 2 or 3 people. Okay, it's closer to 3. I understand that. Okay, but since it's kind of in the middle, it could go either way. But I would expect 2 or 3 of those people to have black hair. Okay. All right. So remember, folks, when you're interpreting an expected value, this is what's going to happen after a large number of times. Okay. And it's pretty easy to compute what the mean is. Okay. But remember, we have to make sure that we interpret it correctly as well. Okay. All right. Questions about how to compute or interpret the mean for this problem? Okay. All right, folks. Next thing we want to do is we want to go ahead and find the standard deviation. Okay, so that's where we're going to have to complete our columns. Okay, so our next column that we need is going to be our x squared. Okay, and that's pretty easy. That's just 0, 1, 4, and 9. And then the last column we need is x squared p of x. Okay, so remember, I'm multiplying these 2 columns. Okay, you're not multiplying these 2. All right, so Don't multiply the ones right next to each other for the last one, okay? It's a pretty common error that students make just because they want to just do things in sequence. But unfortunately, we want to make sure that we're multiplying our x squared p of x. So that's going to be 0 and then 0.0574. And then I'm just going to calculator it. Just lazy and sick. That's 4, so 26008. Right. And then finally, oh no, I think I did exactly what I told you guys not to do. I think I just multiplied the two columns that are right next to each other. Good thing this isn't being recorded. So 4 times 0.3251. All right, so I get 1.3004. All right, and then finally 9 times 0.6141. 5.5269. Okay. Last thing I'm going to do, folks, is I'm going to add these up, and then I can go ahead and throw it into the formula. Okay, so 0.0574 plus 1.3004 plus 5.5269. So I get 6.8847. All right. Now, this is what I'm going to throw into the formula along with this value. Okay, and you guys might remember for our standard deviation, that's the square root of the sum of x squared p of x minus mu squared. Okay, and so what that means is I'm going to go ahead and just substitute these two values and then throw it in my calculator. Okay, so that's going to be the square root of the 6.8847 minus the mean squared. Okay, and the mean or the expected value is going to be our 2.5499 squared. Okay. And remember, folks, you can go ahead and just shove that in the calculator all at once. Okay, and we can get an approximation. All right, so let me go ahead and do that. And again, if you guys can verify this just to make sure we're okay, I'm not making any errors. All right, so I ended up with 0.6186. All right. Now, of course, we're going to be able to check these in this particular problem because I'm also going to ask you guys to use the binomial distribution formulas. All right, but unfortunately, we're just going to have to make sure if we don't do that, then we're just going to have to go off a blind, I guess, observation for this. All right. So going back to the questions, okay, just want to make sure everybody's okay with what we've done so far, okay? And so what we've done so far is we've found the probability distribution, we've used the discrete distribution, and then finally we went through and we found the expected number and the standard deviation, okay? So questions before we go on and use the binomial distribution formulas. Okay. All right, folks. Last thing we're going to do is we're going to check our answers by using the binomial formulas. And fortunately for us, the binomial formulas are way easier. Okay. So going back. So you guys probably remember that for the binomial formulas, okay, and this is the same problem where n is 3, p is 0.85, and q is 0.15. Okay, so for letter D, mu is NP, which is going to be equal to 3 times 0.85. Okay, and in my calculator, 3 times 0.85 is going to give me 2.55. Right. Now, if I go back, remember, we got 2.5499, okay, when we did it using the discrete distribution formula. Okay, so they're actually really close to one another. Okay, it might just be some rounding error or something of that nature. Okay, but it's not so far off that it's incredulous. Okay, all right, we're going to do the same thing with the standard deviation, and we're hoping to get somewhere close to 0.6186. Okay, excuse me. So if we do that, you guys probably remember sigma is equal to the square root of n times p times q, which is the square root of 3 times 0.85 times 0.15. And it's going to be 3 times 0.85 times 0.15. I got 6.185 or 0.6185. And that's pretty close, I think. Yeah, we're only off by 10,000th. Okay, so that's actually pretty good. Okay. All right. So let me pause and ask if there's any questions that I can answer for you all about going through and finding these probabilities and the means and the standard deviations using either the discrete or the binomial distributions. Okay. All right, folks. And I think this is pretty similar to one of the problems that's on quiz number 6. Okay, and I think it's I can't remember which problem it is, but there's a problem where you guys have multiple choice questions. Excuse me. And so for that question, since there's 4 multiple choice questions and there's 1 correct answer, probability should be of success should be 0.25 for that question. Okay, so hopefully that's helpful for you guys for that problem. I got a couple questions from folks about that one, so I just want to make sure I address that. All right, moving on. Does anybody have any other questions that I can answer about anything that was going to be on exam number 2? All right, and what I'll do is I'll share my screen, maybe. Nope, wrong one. I'm trying to bring up the exam review. So that way, if you guys want to take a look at that, I can answer any questions that you all might have. Let's see. There it is. Okay. Sorry about that. Okay. So this was our exam 2 review. So any questions I can answer for folks about any of the problems on the exam review? A typical problem that gives folks a little bit of difficulty is one of these guys with the normal distribution with the percentiles. All right, so that's the one where you have to go backwards and you have to look up the z-score in the table. Okay, so so make sure you guys are okay with something like that one. But all these types of questions are fair game for our examination. Okay, just like we outlined on Wednesday. Okay. All right, so I'm going to stop share because it doesn't seem like anybody has any questions at this point. Okay. All right, folks. So is everybody clear with what's going on for next week? Okay, everybody's good with capstone stuff. You guys know that you're going to create your surveys. Okay, everybody's good with quiz number 6. Everybody's good with the exam. Okay, any questions in general that I can answer for folks? Okay. All right, folks. I'm not feeling too well, so I do apologize. If people have questions, I'll stick around and answer them. But what I'll do is I'll post this video, make sure that you guys have access to it. And then if you guys have questions about stuff, you can email me over the weekend. I'll be chained to my computer, making sure that I answer those. Okay. All right, friends, I will see you all Monday. All right. Hope you guys have a great weekend. Take care of yourselves.